Hi there, welcome to another edition of Mr. Weis Solves an Old AP Problem. Today we're doing AP Calculus BC 2010 number 5. This problem involves a differential equation, dy dx equals 1 minus y. And we're to let f of x be a particular solution to this differential equation with f of 1 equaling 0. We don't know what f of x is yet. I suspect we'll probably find it by the end of the problem. We're also told, interestingly, that f of x is always less than 1 for all x. It's interesting, I don't know where that one's coming from. So part A asks us to use Euler's method with 2 steps to estimate f of 0. So we want to estimate f of 0 with 2 steps. Okay, so this is no big deal. I like to make a little chart to help me out here. So n, we've got x sub n, we've got y sub n, we've got dy dx. Then I multiply that by a delta x to find out what delta y is. And then I add that to the old y to figure out. So at n equals 0, we're starting out at the point 1, comma 0. This is a point we know that is on this thing. And I want to find the derivative there. Well, the derivative is equal to 1 minus y, and y is 0, so I believe this is 1. Our delta x, so our next step is going to be 0.5. Our delta x is negative 0.5. Delta x equals negative 0.5. So I believe that makes our delta y equal 1 times negative 0.5, which is negative 0.5. We add that to our old y value to find our new y value, which is negative 0.5. I'm now plugging that back into the here to find what delta the dy dx is at this point, and it's 1 minus negative 0.5, so 1 plus 0.5, which is 3/2. I'm then multiplying that by negative 0.5 again, so this time we're going to be at negative 3/4. And this gets added to my old y to find my new, my final estimate. So our final estimate is negative 1/2 minus 3/4, which is negative 5/4, I believe. Negative 5/4. Does that make sense? Yeah. So negative 5/4. And so I would probably write here that f of 0 is approximately negative 5/4. And that's my final answer. Okay, here we are doing part B of 2010 number 5 AP Calculus BC. We're dealing with this differential equation, dy dx equals 1 minus y, and we have a particular solution here. In part B, we're asked to compute a limit, a weird limit. So in part B, they want us to find the limit as x goes to 1 of f of x over x cubed, yeah, let me fix that, over x cubed minus 1. Alright, so over x cubed minus 1. Okay, so pretty straightforward, nice limit problem. Here we go. First thing I would do is try plugging in 1. I'm not really plugging in 1, what I'm doing is plugging in, I'm thinking about plugging numbers that are very close to 1 into this fraction to see what I get. And if I'm very close to 1, I'll be very close to f of 1, which we know is 0. And if I'm very close to 1, I'll also be very close to 0 in the denominator. So we are in an indeterminate form situation, 0 over 0. Awesome. So wonderfully, 0 over 0 allows me to use L'Hopital's rule. So this is therefore the limit as x goes to 1 of f prime of x over 3x squared. I can now try plugging in 1 again. So what I'd be finding out right now is what so f prime of 1, note that f prime of 1 is dy dx at x equals 1. And dy dx at x equals 1 is 1 minus whatever y is when x equals 1. And what is y when x equals 1? It turns out that it's 0. So this is 1 minus 0. In other words, this is y of 1. Remember, we know that, or f of 1. We know that f of 1 to get 0, so that's going to end up being 1. And so in the numerator here we have 1, and in the denominator we have 3, and the answer is therefore 1/3, and that's my final answer. Okay, here we are on the final part of the 2010 AP Calculus BC exam, problem number 5. And in this final part we're going to actually solve the differential equation, which we've been fooling around with for the first 2 parts. This is what we call a separable differential equation, which is effectively the only differential equation that you learn how to solve in BC Calculus. So here we go, let's get to it. The idea of a separable differential equation is to try to get all of the y's and the dy's on one side of the equation and the x's and the dx's on the other. This is very simple in this case because we simply have dy over 1 minus y equals dx. I then integrate with respect to the appropriate variable on each side of this equation. And on the right-hand side, I simply get x plus c. On the left-hand side, one really could do a u substitution if necessary. I personally am not going to do a u substitution. I talk about this in class all the time. You should be able to handle something like this. The bottom is a linear term. It's definitely going to involve a natural log, and there's an easy check to make sure that you're doing it right. So here we go. I think the answer should be the natural log of the absolute value of 1 minus y. However, if I take the derivative of this with respect to y, I would get 1 over 1 minus y times the derivative of 1 over 1 times the derivative of 1 minus y, which gives me a negative. So therefore this is not correct. I have to throw a negative in front of this. Okay, and now the goal is to simply figure out what y is. At this point though, if I wanted, I can plug in the fact that I know. I might as well do this right now. I know that f of 1 is 0. I know that when x equals 1, y is 0. So I can plug that in right now to figure out what c is before I go through the rest of the process. I generally tend to do that because I'd rather work with c as a number, which turns the rest of the problem into basic arithmetic, with some algebra involving x's and y's, rather than leave it as a c, forcing me to do algebra with 3 variables instead of just 2. This isn't always the case, but it generally is a plan I would do. So let's plug in x equals 1, and we're going to get 1 plus c equals negative ln of 1 minus 0, which is ln of 1, but this is just 0, and so we just found out that c equals negative 1. Okay, so let's go back to our, I'll write this down now. Down here now, we have negative the natural log of the absolute value of 1 minus y equals x minus 1. And we're going to try to solve this for y. So I'm now going to multiply both sides by a negative. I will get the natural log of the absolute value of 1 minus y equals 1 minus x. I'll then e to the both sides, and we'll get the absolute value of 1 minus y equals e to the 1 minus x. Okay, this is interesting. Where we're currently sitting, I might want to say something like 1 minus y equals plus or minus e to the 1 minus x, but I think here is finally where we're going to use this fact that we were given from before, which is that f of x, in other words y, is always less than 1, which means that this term right here, this absolute value, is not actually necessary. We don't really need it. The y is always less than 1, which means 1 minus y is always going to be positive, so I can get rid of the absolute values. I did say at the beginning of this problem that it was quite weird that they gave us this information. There had to have been a purpose. So I can therefore ignore the absolute values, and I can simply solve for y. So we have 1 minus y equals e to the 1 minus x. Move the y over and move the e over, and I get y equals 1 minus e to the 1 minus x. And this is my final answer.